Hello everyone, welcome back to mathematics class. I am Michael. So our last time on the mathematics, we discussed about limit of function and the methods with which you solve questions involving limit of function. We discussed about our methods like the rest substitution method, our factorization method, and today we're discussing our solving problems that has to do with limit of a function using L-Hopital rule. L-Hopital rule. So here we have two examples, example 1, example 2. If I give you examples like this, what is the first thing we need to consider? Whether we have to use substitution method or factorization method or L-Hopital rule. The first thing, if it is a quotient, like we have division like this, something over something, where we have a numerator and denominator, the first thing to check is that you directly substitute the value of x naught, which happens to be 4, okay, to the denominator. If it returns 0, it means this expression will be undefined. So in that case, we cannot use direct substitution method. It's either we use our factorization method or L-Hopital rule. Do you understand? But when I was explaining factorization method, I said that if you have our difference of squares, we can actually factorize the numerator and rule out in some cases. You understand? But in this case, our L-Hopital rule, we cannot factorize anything out that will resemble numerator here. You understand? So in that case, we have a very quick shortcut we use to solve problem involving our limit of function using L-Hopital rule. Let's firstly try it. If we should use direct substitution, will it give us something other than 0 as denominator? Let's try it. What's our denominator? We have our x squared minus x minus 12 as x tends to 4. Now let's input the value of our x, which is 4, and see what our answer will be. From here, we have 4 squared minus 4 minus 12. I hope you are following. And 4 squared give us what? 16 minus 4 minus 12. Minus 4 minus 12 will give us what? Give us minus 16, 16. Now, 16 minus 16 will give us what? Will give us 0. It means this denominator will be what? 0. If you should use direct substitution method from here. And it will render this expression undefined. So in that case, we cannot use direct substitution method. So let me clear this. All right, moving further. So far we cannot use direct substitution method here. I will say that we are going to use L-Hopital rule. So how do we do this? Very, very simple. No differentiation, right? Let us write this our question. We are limiting the expression as x tends to 4. And what's the expression? We have x minus 4 all over x squared minus x minus 12. Now pay attention here, please. If you want to solve this using L-Hopital rule, the thing you need to do is what? Is to differentiate this whole expression, but not like our usual differentiation. I don't know that you're following. What to do here is this. You take this value, this x, you differentiate it, you leave it. You take 4, you differentiate it, you leave it, like you take it one after the other. You understand? For instance, normally if you want to have normal differentiation, for this kind of question, we're supposed to differentiate using quotient rule. But that's not apply here. What we do is that you take each of this value one after the other and differentiate them. So let's go and I'll see how it works. Limiting the expression as x tends to 4. Now, if we should take x and differentiate it with respect to x, we are going to have 1. We take 4 with respect to x. 4 is a constant, so it returns 0. We have 1 minus 0 all over x squared will give us what? That should give us 2x minus x to give us 1, and 12 will give us what? 12 will give us 0 as a constant. Are we together? Now, we have this. Let's try and make some amendment. Let's rearrange to clear all these zeros. So here now, we're supposed to have something like our limiting expression as x tends to 4. So now we have 1 minus 0 is going to give us 1 over 2x minus 1, 0, 0 gone. So now we have 1 over 2x minus 1. Let us now check the first thing we did here, we should put the value of our x naught in this expression, whether we are still going to get an undefined expression or not. Okay? The value of x naught is 4. We should put the value of 4 in this denominator. We're going to have 4 times 2 minus 4 times 2 and minus 1. 4 times 2 will give us what? It will give us 8, minus 1 will give us 7. So it means our denominator is not going to be equal to 0. So now, by substituting the value of x naught, which is 4 into the expression, we are going to have 1 over 2 bracket x, which is equal to 4 minus 1. So in that case, we're going to have 1 over 2 times 4 gives us 8 minus 1. Okay? And this is equals to 1 over 8 minus 1 is equal to what? 8 minus 1 gives us 7. And that is the last answer. I believe you understand. Now moving forward to the question number 2. Example question number 2. We have the expression 1 minus cos theta over theta as we limit the expression as theta tends to 0. The same thing we did here. We directly substitute the value of theta into the expression and the denominator returns 0. We cannot use the rest of the method. Now, if you put value of theta here is going to give us 0. It means the rest of the method will not work here. So, the next we are going to do is to differentiate this one after the other. Let us write the question. We have the limit of as theta tends to 0. Then we have 1 minus cos theta all over theta. But mind you, here we differentiating with respect to theta and not x. So we're gonna have it's gonna give us still missing the expression as theta tends to 0. Then if you differentiate this one with respect to theta, we are going to have what? We are going to have 0 because the constant. And if you differentiate, we have negative a before, this is minus. If you differentiate cos theta with respect to theta, we are going to have minus sine theta. I believe you understand how we get minus sine theta. Then all over the derivative of this theta will give us what? 1. So we have this. Moving further, if you now input the value of theta into this expression, are we still going to get 0 as denominator? No. Denominator remains what? It remains 1. So from this state now, we can directly substitute the value of our the value of our theta into the expression. Let us do that and see what we get. Equals to, we have 0, okay, let me try and write this, let me try and write this to be more clear. Let me see the expression as theta tends to 0, then we have 0 will vanish. And we have minus, and minus will give us what? Positive. So it means for the numerator, we have only sine theta over 1, which is still equals to sine theta. Now, if you put the value of theta here, we are going to have sine 0. And from our trigonometry, we should know that sine 0 gives us what? That would definitely give us 0. And that is the last answer for this. The procedure is this. If you are given something like this in quotient, firstly test the rest of the method. Taking the denominator, use the rest of method. If it gives you 0, it means we cannot use the rest of method because the expression of the word is beyond defined. Now, I'll say that I use factorization method or L-Hopital rule. If you have to use L-Hopital rule, we are going to differentiate each of these givens in the expression one after the other. Then we test again if the denominator will return 0. If it doesn't, then we substitute. If it does, then you will differentiate. That's how we solve problems involving limit of function using L-Hopital rule. Thank you very much. See you in the next class.